Hi guys, Buildzoid here, and today we're going to be taking a look at the voltage regulation and LLC settings of the Asrock B650 Live Mixer motherboard. Before we get into this, I'd just like to thank all of my patrons and supporters, because without you guys this video wouldn't be possible, because I had to buy the motherboard and the 7950X, and also the oscilloscope. So anyway, huge thank you to everybody who supports the channel for making videos like this one possible. If you'd like to support the channel, there's links down in the description below. With that out of the way, let's get into it. So the test setup here is a 7950X. It's just at a static 4.8 gigahertz because if we're going to be testing the voltage regulation and transient response capabilities of the board, then we don't want the boost system getting in the way with its dynamic voltage, adjustments. So static 4.8 gigahertz. I have the memory, the memory is also overclocked because we're going to be using LinPack as our load, and LinPack is very sensitive to memory settings, so here's just some, these timings aren't verified for 100% stability, though I would be kind of surprised if they weren't completely stable. Yeah, so here's the timings if you wanted to, copy my test methodology. These are the timings you would need to use. And that's just running at DDR5 6000 with 2000 megahertz on the Infinity Fabric UCLK equal to MEMCLK. So the memory controller and the memory clock are synchronized, but the Infinity Fabric, of course, isn't synchronized because it doesn't do 3 gigahertz. Anyway, for the voltage settings, initially we're going to start with 1.1 volts and level 1 LLC. This is the most aggressive amount of LLC that this board has. And the voltage regulation at level 1 LLC is terrible. Yeah, it's really bad, as you will see soon enough. So we're just going to save and reset. And while that's booting up, let's talk a little bit about the measurement setup. So the oscilloscope is connected to the V-core of the motherboard through just a piece of coax. There's a 50 ohm termination at the oscilloscope. The coax is connected to the bottom rightmost multi-layer ceramic capacitors of the behind the CPU socket. So this is not the most accurate way of testing voltage regulation on a motherboard. Ideally, we would be taking voltage measurements from the CPU package, so not from the motherboard itself. But the thing is, I don't really want to deal with soldering coax to a 7950X. It's not technically not impossible, just not particularly fun to do. And I already had one 7950X die. I don't really feel like risking another one for slightly more accurate measurements. So basically the reason why measuring from the motherboard is not as accurate as measuring from the CPU package is that measuring from the motherboard, we have the CPU socket impedance between the die. So we're not, the oscilloscope isn't seeing the same voltage that the actual transistors of the CPU are seeing, because there's the socket impedance between where the oscilloscope is connected and the actual silicon. Anyway, as for what the oscilloscope set to, it's 100 megahertz bandwidth, 10 milliseconds per division, and yeah, so that's the test setup. So now we're just going to run some LinPack and see what the voltage regulation looks like. Oh, I guess I should explain what the measurements we're going to be paying attention to. So max voltage is just the highest voltage that the oscilloscope is measuring. Average voltage, this is what basically dictates your CPU's power consumption, is the average voltage that's going to the CPU. And then we have the minimum voltage, and this dictates the CPU's stability. Basically, if the voltage dips too low for the frequency you're trying to run during the workload you're trying to run, it'll crash. So yeah, we want, basically, a good motherboard will have a very small difference between V-min and V-average. And with minimum, you have the average minimum voltage. So, because basically the oscilloscope is taking these measurements multiple times. So it takes an average of the minimum voltages that it has seen over a period of time. And then there's the absolute minimum value over here, which is just the lowest voltage that it measured since, I've reset the measurements. So if I reset the measurements, the minimum voltage gets reset. And for the average voltage, we're going to be, focused on the average of the average voltage. because moment to moment the average voltage can go up and down a little bit, and that doesn't really matter that much. So anyway, a really great motherboard will have the minimum and the average minimum are going to be very close to the average voltage. And the maximum voltage just kind of doesn't matter. Technically, you could get motherboards where you have so much overshoot that it's potentially dangerous to the silicon. In practice, if your motherboard has major overshoot problems, it probably sucks at undershoot anyway, and it shouldn't be used. So, yeah, so, the max voltage measurement is just kind of there. It's not really something I generally care about on really ever. So, anyway, let's actually start LinPack. So starting out, LinPack has a bit of a warm-up phase. Most of these little spikes that we're seeing everywhere, those are actually the Windows event timer. And now LinPack is running properly. And I'm just going to pull the trigger in on the waveform. Come on, there we go. And we're going to try trigger on some of these really low voltage spikes. So basically, what we're seeing here, and I guess we should just pause it for a bit. And so basically what's happening is in this area where the voltage is just very, it's relatively stable, but, a squiggly line because it's never going to be a perfectly flat line. This is where LinPack is actually running. And then what happens that causes this spike right here, as well as this spike over here, is that Windows basically periodically interrupts the workload. And when it does that, LinPack goes from pulling 200, well, with the settings we're running right now, close to 200 amps to pulling maybe 20. And that causes that massive upwards voltage spike, which isn't really that much of a problem. This right here, again, the peak of that spike, it's not dangerous to the CPU, right? That's just 1.26 volts. Obviously, if we had a higher average voltage instead of average voltage of 1.123, if we had an average voltage of, I don't know, 1 point, because what is this? This is 130 millivolts. Yeah, this is 140 millivolts above our average voltage. So let's say we had an average voltage of 1.4 volts, then the spikes would be hitting 1.54 or something like that. This still wouldn't really be a concern, right? Because these spikes are very short, and they specifically happen when the CPU is pulling very little current. So we don't really have to worry about them. However, the downward portion of this spike, this is actually a major problem, because the reason why this happens is that if we zoom in some more, and I'm actually going to grab a new sample of this there, basically what happens, so, LinPack is happily doing its thing, then it gets interrupted by Windows, and then right around here, as the voltage regulator is trying to, bring the voltage back down to where you kind of want it to be, LinPack resumes, and the current draw goes from, 20 amps or something back to 200 amps, and that causes the voltage to just nosedive very, very quickly, and we get this downward voltage spike. And the bottom of this right now is 1.0478 volts. Right, whereas our average voltage is around 1 point, this part right here, once the voltage regulator actually recovers from the transient, that's around 1.12 volts. So this right here, for a short period of time, the transistors, in the CPU, instead of being fed 1.12-ish volts, they're getting actually they're getting even less than what we're seeing on the oscilloscope because of the CPU socket impedance. But if we just pretend that the CPU socket impedance isn't real, for a short period of time, those transistors are getting, 90 millivolts less voltage than average. And, if your frequency is too high for this very low voltage, it's just going to crash. Now, it's not doing that right now because the reason I specifically chose 4.8 gigahertz is because it's such a low frequency that it's very tolerant of even large voltage deviations like this. But yeah, if I was really trying to max out the CPU, these kinds of voltage deviations are a major problem because they do cause the CPU to just straight up crash. Anyway, so we're going to zoom back out of this. We're going to let this run for a bit. Oh, there. I'm just going to reset the statistics. So we're going to actually have a, well, I'm going to reset it once LinPack starts doing its thing again. There we go. So I'm just going to reset that. And we're going to, let the oscilloscope basically take a bunch of measurements and then look at the results. And we're going to wait for like 300 samples. And so we're right about there. I'm going to stop it. So we can see that when LinPack is actually running, our average voltage is about 1.123 volts. And on average, the undershoot is about 1.044 volts. So that's about 90 millivolts off. But in the worst case scenario, it drops down as low as 1.0283 volts, which is about 100 millivolts off. So yeah, level 3 LLC, level 1 LLC really kind of sucks, is the best way to put it. Like, we're getting massive amounts of undershoot. And so if you were actually trying to do a static overclock with this, you need significantly more average voltage just to maintain a, maintain a reasonable minimum voltage. So yeah, level 1 LLC, unsurprisingly enough, is terrible because level 1 LLC is the most aggressive LLC setting that this motherboard has to offer. And the norm is that the most aggressive LLC on any motherboard will just generally be very bad. So that's really not surprising. Did I press shut down or restart? I think I hit shut down, which was a mistake. Anyway, so now we're going to try level 2 LLC. Now, because level 2 LLC obviously has higher V droop, we're going to need to set our target voltage a bit higher. So instead of 1.1 volts, we're going to be going up to what is it, 1.15. No, 1.115. There, I keep forgetting the extra one. And nope, that's the wrong submenu. Anyway, so the other thing about this board that I'm not really, this is a BIOS thing, this isn't a voltage regulation thing, it's just a little thing that I kind of find annoying, is this, okay? You set your LLC setting to something, and then you change the voltage, and the LLC setting gets changed for you. It's not the end of the world, especially since the level 2 LLC isn't that bad. It is still worse than level 3, but yeah, not the end of the world, I guess. Anyway, so let's take a look at, what kind of a job level 2 does. It's spoiler, it's not great. It's better than level 1, but it's still it's significantly better than level 1, right? So level 1, we were seeing the minimum dip all the way down to 1.028 volts with an average of 1.123. Now I'm expecting to see a similar average voltage, maybe a little bit lower, and we should be seeing about 20 millivolt higher worst case scenario undershoot. So instead of 1.028, we should be seeing 1.05-ish. Maybe a bit less than that. Or maybe a bit more than that, but no. Oh, there we go. So we're just going to go straight into LinPack now. No. I'm just going to note down the previous... Oh, wait, that's the wrong keyboard. So, yeah, actually now you can see that the trigger is set a little bit too low because the spikes aren't as low as they used to be. So the trigger isn't catching them all now. Which, that alone just shows you what a... Yeah, actually, I still need the trigger a little bit higher. But yeah, we're getting about 1.052 instead of 1.028. So quite an improvement. The average voltage was relatively similar. Actually, the average voltage was a smidge lower. So we're actually getting lower average voltage, so slightly less CPU heat, and its average voltage is only down a millivolt. So, it's still technically less heat. But our minimums are higher, so our CPU stability is actually better, right? if I reset the statistics again, like you can see, our average voltage is now 1.1222 volts. So, pretty close to the 1.123 that we had before, but now we're getting like 1.048, 1. Yeah. Okay, so now we got a pretty big downward spike, but still much better than the 1.02, what was it, 1.028 that we were seeing before. So it's about a 20 millivolt improvement. Still not great though. This board's kind of lucky that you guys haven't seen what Asus boards do yet. Because basically, and the thing is, like, if I compare, like, so both Asrock and Gigabyte have a very simple issue with their LLC settings. Neither of them gives you enough V-droop. Whereas on Asus boards, you can set some completely ridiculous amounts of V-droop, and consequently, you can actually get the voltage regulator set up such that there is no undershoot. The average voltage, or not no undershoot, there's still, the voltage is never going to be a perfectly straight line, but on Asus boards, you can get the LLC set up so that the difference between your, average voltage and your minimum voltage, instead of being like 90 or 100 millivolts, it's like 40. Which is really, really good. Like the best motherboards and GPUs I've ever measured are in the range of like 30 millivolts generally, between minimum and average. So, yeah. Anyway, so now we're going to try level 3 LLC. For level 3, we're going to need another 15 millivolts extra. Because the goal is we want the same average voltage, right? Like the CPU's power consumption, its operating temperature, it's like that is dictated by the average voltage. So we want the average voltage to be the same across all test scenarios, but the minimum voltage is what's going to cause the CPU to blue screen. At least if I was actually trying to go for a, edge of stability overclock. Which we're not doing here because it makes, like, it's kind of a pain to, like, if Asrock had like a level 4 LLC or an even higher V-droop LLC, I might demonstrate the difference, but the thing is the LLC settings on this board are kind of close together. It's only like a 30 millivolt improvement between level 1 and level 3, so while level 3 is better, it's not that much better, and so doing a reliable demonstration of like, look, this overclock works at this really droopy LLC, but doesn't work at this very aggressive LLC, I can't do that because the difference between the droopiest and the least droopy LLC on this board is not much. We went from 1.1 volts to it's 30 millivolts, literally. Which is a funny coincidence how that works, that, if you have 30 millivolts higher set voltage, your undershoot is 30 millivolts better. It doesn't necessarily always work out like that, especially once you get into like, because the thing is level 1 on this board is still not 0 V-droop. Which is a good thing, because, yeah, there are boards where you can set the LLC so, like, you can set 0 V-droop LLCs, and then the voltage regulation just goes, like, that's the main reason I'm using 4.8 gigahertz here, is because the really, really aggressive LLC, like, even, actually, I think on some boards, even 4.8 gigahertz with maxed out LLC wouldn't work. Anyway, let's run LinPack again. And so we get the little warm-up phase, and now it's running. And I'm just going to clear the statistics, and you can see that, our minimums now are like 1.063 volts instead of like 1.048, 1.005. And on average, we're seeing about 1.01. So, yeah, quite an improvement. Our average voltage is actually, it's actually higher. It's at wait a minute. Did the board set the LLC back to level 2? Did I change the LLC first and then change the voltage? And this is why, like, this is actually a relatively minor annoyance for an Asrock motherboard, because the worst level of BIOS automation that I've encountered on an Asrock board is that, like, changing the memory ratio would change a bunch of memory timings, which was just, don't do that. If you make a motherboard BIOS, do not automatically adjust settings for people. Oh yeah, we're at level 2. So, yeah, it changed it for me. I hate that. I hate that so much. No other motherboard vendor does this. Like, this is exclusively an Asrock thing. Like, you can't even punch in your voltage without Asrock trying to change your LLC for you, which is not a huge deal. It's just really annoying, right? Like, the board shouldn't do things that you didn't tell it to do. Yeah. So let's get LinPack going again. Oh, I reset it before it even started, so it doesn't really matter. Anyway, so now we should have similar average voltage again. Yeah, so our average voltage is now back to around 1.12 volts. It's actually a bit lower. It's 1.121. So we're down about a millivolt or 2 millivolts from level 1 LLC, but our minimums are at 1.06. Well, now it dropped down to 1.058. So yeah, the thing is, like, even level 3 LLC it's not much better than level 2. Mostly because the difference between level 3 and 2 is 15 millivolts, so it's kind of what you'd expect. This is the one reason I'm willing to forgive the board for automatically setting level 2 LLC, is because level 3 is like 10 millivolts better. So, you know, the fact that it defaults to level 2 is just like, and, you know, it's not, like, because level 3 is also kind of bad. Like, ideally, this board would have, like, a level 4 or level 5 LLC, at which you'd need to set, like, 1.15 volts or 1.18 volts or something. Because the LLC as it is implemented right now, you just can't set a high enough amount of V-droop to, you know, get the downward spikes to sort of be closer to the average. Right? Like, we're still seeing 1.06 relative to a 1.12 volt average, so that's still like 60 millivolts of undershoot, which is better than the 70 that we saw at level 2, but it's not it's not a very big difference. And level 1 is just unusable. But yeah. Anyway, so that's it for the voltage regulation on an Asrock B650 Live Mixer. Now, ultimately, this only really matters if you're doing static overclocking. If you're doing PBO, this doesn't really affect anything, because the reason why so many AM5 motherboards have these extremely shallow LLCs and or like extremely aggressive load lines is because of the AMD spec for the boost, like the stock boost system. So if you're just messing with PBO, this really doesn't affect you. But if you're doing static overclocking for benchmarking purposes, so, you know, like Cinebench, 3D Mark, that kind of thing, yeah, having having LLC levels like this where you just can't get the undershoot under control, not ideal. It's not a huge problem. Like, for day-to-day use, this really isn't too much of a problem. But yeah, if you're doing static overclocking, this is actually really annoying. Because you just need like a significantly higher average load voltage in order to achieve the same level of stability as you would if you had a motherboard with better voltage regulation, which we will be looking at some of those, or more like one of those in the near future. I haven't I'm planning to do a video with the B650E Strix from Asus, which I expect to, well, beat this. I really do expect it to beat this. But yeah, anyway, So if you do have a B650 Live Mixer and you are, or actually any of the motherboards with a similar VRM to this, because this board actually, I think there's like the B650 RS, there's like a bunch of B650 boards from Asrock which have basically this VRM. Yeah, all of them are going to behave like, all of them should behave like this. I don't, it doesn't make sense to me that they would all have like different VRM firmware. Then again, this is Asrock, so at the same time, it wouldn't really surprise me if that was the case. But yeah, if you have one of these boards with a similar VRM to this one, you probably want to use level 3 LLC. Level 2's not level 2's not much worse, but level 1 is actually just bad. I mean, honestly, I think level 2 and 3 are also bad, but the difference between 2 and 3 on this board is not that big, so in a way you could kind of say it's the fact that they default to level 2 is not too much of a problem, I guess, considering that level 3 isn't really that much of an improvement. But either way, I really wish there was just like a level 4 or level 5 LLC on this board. So, yeah. Anyway, that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon as well as a Bandcamp, and there's also a Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. So yeah, there's links to all of that down in the description if you'd like to support the channel. That would be much appreciated. And yeah, that's it for the video. So thank you for watching, and goodbye.